In this video, we are going to understand the concept of linear block code. There are various types of block code such as Hamming code, linear block code, cyclic code, convolution code, etc. So why these codes are called block code? Because the coding is done in the form of small blocks of data or small blocks of bits. Like for example, there is a stream of data of 128 bits. So what we can do is we can divide those 128 bits into 16 bits blocks, and then we will perform some operation on those blocks. So that is why these type of codes are called block code, and this data is transmitted through the channel. So that is why these codes are also known as channel coding. So it can be termed as block code or channel code. So in this video, we are going to understand the concept of linear block code. So first we will understand how linear block code is generated, and then we will take an example to understand it better. So basically in linear block code, there is a generator matrix of n comma k, where k is the length of data and n is the length of code. So basically it will be given to you in the exam. That means the value of k and n. So if you know the value of k, that means you know the length of data. Like for example, if k is equal to 3, so you know that the length of data is 3. So by combining zeros and ones, how many different combinations of zeros and ones with length 3 can be produced? 2 raised to the power 3, that is 8. Starting from 000 till 111. So all the 8 possible combinations will be considered as your data, and then we have to convert this data into its corresponding code, and the code length will be n. It will also be given to you. Suppose you have given 6,3. So that means you have 3-bit data and you have to generate a 6-bit code. Okay. So this G comma A will be a matrix structure, and this matrix structure is something like this. It is divided into two parts. The first part of this matrix is I, and the second part of this matrix is P. This I is nothing but a unit matrix. We have already studied this thing in mathematics. This P is a parity matrix. So this parity matrix is useful for the generation of code. So in exam, you will be given a matrix and the value of k as well as value of n. If all these things are given, we will be easily going to calculate the linear block codes. So how various values of these codes are calculated? There are some formulas. The first formula is Ck is equals to dk. Ck is equals to dk means if the linear block code is 6,3 linear block code, that means the length of data is 3 and length of code is 6. So till the length of 3, your code is same. That means bit d1 is equal to c1, bit d2 is equal to c2, and bit d3 is equal to c3. 3 bits will be same as code. By this formula, Ck is equals to dk. Then Ck plus 1. Ck plus 1 means if k is equal to 3, that means 3 plus 1, this will be C4th bit, that is the 4th bit code. It will be calculated by d1 into p11 XOR d2 into p21 XOR d3 into p31 XOR, and so on. Like for example, parity matrix is a 3 by 3 matrix. Then P11 will be the first row and first column element, 21 will be the second row, first column element, 31 will be the third row and first column element. That means logically it is the first column of the parity matrix. Similarly, Ck plus 2 will be d1 into p12 XOR d2 into p22 XOR d3 into p32, and so on. P12 means first row second column, 2 2 means second row second column, 3 2 means third row and second. So that means the second column of this parity matrix is used for the calculation of C5 bit. Similarly, C6 bit will be Ck plus 3, and it can be calculated using D1 into P13 XOR D2 into P23 XOR D3 into P33 and so on. 1 3, that means first row third column, 2 3 second row third column, 3 3 third row third column. So that means this element. So accordingly all the elements are multiplying with what? D1, D2 and D3. So that means suppose you have to calculate a 3-bit code. So the data is fixed, that is D1, D2, D3, these bits are fixed. Let us take an example and then you will be going to understand this concept better. This formula is basically just for your knowledge. Even if you don't remember this formula directly, you can also solve the question. How? That we will see in the numerical. Like 1 0 0 0 1 0 0 0 1 0 1 1 1 0 1 1 1 0 G6 comma 3. Question will be something like this: for the given linear block code, find all the code words. So just by viewing this, what all things you are understanding, that the length of data is 3, length of code is 6, this is the unit matrix and this is the parity matrix. So if this is the parity matrix, this element is nothing but P11, this element is nothing but P21, this element is nothing but P31, this element is P12, 22, 32, 13, 23, 33 and so on. So these are the elements which we have already used. So even if you don't remember the formula, for C4 bit you have to use this column, for C5 bit you have to use this second column, and for C6 bit you have to use this column, right? So let us take example data 010. You have to convert the 3-bit data 010 to its corresponding code. So as per Ck is equals to Dk, we know that if it is D1, if it is D2 and if it is D3, your C1, C2, C3, C4, C5 and C6. D1 will be C1 0, D2 is C2 which is 1 and D3 is C3 which is 0. That means first 3 bits will be same as data. Now we will be calculating C4, C5 and C6. So for the calculation of C4, that is Ck plus 1, our D1 will be 0, this is 0, P11 is 0, that means 0 into 0. Now you are XORing, then D2 is 1, P21 is also 1, 1 into 1, and then D3 is 0, and we are multiplying this with 1. So 0 into 0 is 0, 1 into 1 is 1, and 0 into 1 is also 0. Now you are XORing the results. So 0 XOR 1 is what? 1, and then 1 XOR 0 is what? 1. You know the XORing of the values or the binary data. If 0 XOR 0, then the output will be 0. 1 XOR 1 also be 0. And if it is 0 XOR 1, that means if the same bit is XORed, the output is 0. And if the different bits are XORed, that is 1 and 0, output would be 1. So from this calculation, your C4 bit will be 1. Now similarly, we can calculate C5 bit. For C5 bit, your D1 will remain same 0, but now it will be P12, which is this value 0 into 1. Then this is 1 and this is 0, and then this is 0 and this is 1. And again you are XORing this result. 0 into 1 is 0, 1 into 0 is 0, and 0 into 1 is 0. All the outputs are 0. So 0 XOR 0 is 0, 0 XOR 0 is 0, so that means C5 bit will be 0. And similarly C6, 0 into 1, because it is P13, this element, then XOR 1 into 1 XOR 0 into 0. So 0 into 1 is 0, 1 into 1 is 1, or 0 into 0 is 0. 0 XOR 1 is 1, 1 XOR 0 is also 1, so this value is 1. So this way you have calculated code for data bit 010. So your data is 010 and its corresponding code is 010101. This is how a 3-bit data's 6-bit corresponding code is generated using linear block code. Same way we can calculate any other example, 011. So again for 011 I'll go quickly. 011 C1 C2 C3 will be 011, and then 011 is multiplied with this, the result will be 0, 1 and 1. So corresponding code is 011. I have just multiplied 011 with this to get C4, then second column to get this, and then third column to get this. I think it will be understood. So this is how you can create or you can generate all the codes related to the respective datas for any linear block code. Like for example, if it is 7,4, that means the data will be of 4-bit and the code will be of 7 bits. If the length of data is 4, how many datas can be generated? 2 raised to the power 4, that means 16 different data sets can be generated starting from 0000 to 1111. So all those 16 4-bit datas can be converted into its corresponding 7-bit code using a matrix which would be given to you in the exam. So that way you will be able to generate linear block code. I hope you understand the concept. In the next video, we are going to understand the concept of cyclic code, which is also a type of block code.